Hi, everyone. I'd like to welcome you all to this, which is the first session of the International Industrial Ecology Day. So we're actually kicking it off. And for those who don't know, the International Industrial Ecology Day, it's basically a 24-hour virtual event that kind of brings the global industrial ecology community together to basically discuss and I guess come up with ways of kind of bringing the entire field forward. I'll just apologize as well. I've been coughing a little bit the last few days. Now, this first session is on ideas for improving mineral and metal supply chain data sets and analysis. But before we get into that, I might just show, I guess, a bit of the broader program here. So in the Industrial Ecology Days website, there's a page that basically has all the sessions that are available. The default time shown are in UTC, so the Universal Time Code, so GMT. But up the top, you can just kind of put in your location and it will change all the times to your local time zone. And so I'll put the link. So just give me a second to do that. And here's a list of, I guess, all our wonderful speakers for today. And so there's me. So I'm Dr. Stephen Northey. I work at the University of Technology, Sydney in our Institute for Sustainable Futures. And then our presenters / panelists are Dr. Juliana Segura-Salazar from the Sustainable Minerals Institute at the University of Queensland, Professor Peng Wang from the Institute of Urban Environment at the Chinese Academy of Sciences, Phoebe Wadoff, one of the directors for Minviro, Professor Damien Jerko, who's also with me here at the UTS Institute for Sustainable Futures, Professor Mohan Yelishedi, from the Resources Engineering Group at Monash University, Professor Vladimir Strezov from the School of Natural Sciences at Macquarie University, Bernardo Mendonça Severiano, who's doing a PhD here with us at the UTS Institute for Sustainable Futures, Tim Werner from the School of Geography at the University of Melbourne, Dr. Parvez Mahmood from the Faculty of Science here at UTS, and Associate Professor Wen Li from the Department of Mechanical Engineering at the University of Melbourne, and Dr. Jim West from the Commonwealth Scientific and Industrial Research Organisation here in Australia, CSIRO. So it's a big list of speakers, so I won't read out everyone's full bios, but you can find in the chat just a link to, I guess, everyone's broader bios, and you can learn more about them that way. So the way that this session will be structured, it's basically in two halves. So the first half, each speaker will be giving basically a 2 to 3 minute presentation of one of their ideas for kind of improving the way that kind of minerals and metals are accounted for or kind of analyzed within industrial ecology. As each speaker is speaking, after 2 minutes, I'll raise my hand just to kind of give you a bit of a signal to start wrapping up. And after 3 minutes, I'll cut you off. Then in the second half of the session, will be, I guess, more focused on discussion. And as part of that, both audience and presenters will be able to ask questions by raising their hands. And we'll try to keep the responses to those questions fairly short and sharp so that, everyone gets a chance to kind of respond to questions. And so presenters will be given up to 1 minute to respond to any individual question. So without further ado, I'd like to hand over to Juliana.
Hello, everyone, and thank you, Stephen, for inviting me to speak today. So basically, today I want to pitch something starting with highlighting the essential role that mineral-rich developing countries play in the current and future mineral resources supply for the clean energy transition, but also for global human development. And we see recent statistics from IEA's report on the global critical minerals outlook, highlighting regions as China, Latin America, Indonesia, and Africa will continue to increase their market value for the mined resources. And China, of course, has a key role in concentrating the market value for refining. And historically, developed regions like Europe and USA have driven LCA methodological development in terms of impact assessment methods and also databases, with some progress from in terms of regionalization approaches. But it's clear that more capabilities are required for developing mineral-rich regions to have the adequate tools to enable a sustainable energy transition. And in the case of LCA, this, of course, can be done by improving the resolution and quality of LCA studies with complementary tools and approaches like process simulation, machine learning, or GIS, for instance. But we also need long-term and coordinated efforts to build and sustain LCA capacity in developing regions. And this includes training and database development and maintenance, ideally in an open access way, although this has been very challenging. And we could leverage learnings from other initiatives and partners as well. And I'm very keen to contribute to this effort. So this year, I started to develop a specialized LCA training course for professionals in the mining industry. And my goal is to continue evolving this work next year, ideally through an online learning platform with the support of SMI's transformational learning team. So I look forward to hearing any thoughts or comments and suggestions from the audience. And thanks. Thank you very much.
Thank you, Juliana. Okay, so next up we have Peng Wang.
Yeah, so hello everyone. Today I'm going to present my understanding and call for some initiative called Global Mining ESG Initiative, which is going to focus and promote. So the first thing, ESG, I think ESG has been gradually recognized by mining companies and the government and at the UN level. We all focus on ESG. ESG has a go well beyond the LCA or other kind of categories. So it's very critical. But if you check the current understanding, mining ESG is quite limited. So what I'm going to do or share the pathway we can create is the first one, focus on the mining activities. So we know that so many activities are spanning on the world, and a lot of them we don't have data. We don't know where they are doing now. So we need to focus on each mine side by side through different data sets and those technologies like remote sensing to detect and to monitor the activities. And also, because if you compare like for similar mines, there are so many differences on the environmental impact. Like every report for nickel mining, the carbon footprint can be the difference can be like 100 times high. So normally we use average data, which doesn't work out. So that's the reason why we need high resolution analyze and the data sets built for that. And the second one is on the ESG standard method. Currently, there's so many ESG standard and method, but like from scientific background or scientific understanding, so we need to cooperate on that. Not only propose some new standard or new method, but also encourage this standard with LCA, with other kind of indicators we have. So that's a lot of work, and we need also to double check whether this ESG standard is good or not, can really like focus or really reveal the ESG impact of mining activities. So we need to promote a very good scientific sounded method and standard for ESG, like from academia and from research perspective. A little one, so we have this data, we have standard. How can this can be used for like industry or for government or for United Nations? So we need a modeling platform. This is currently we are doing now. We are building the platform, digital Earth platform to encourage mining activities and some basic information of that, and then use some technique and also use some standard method. We can capture the ESG performance of each mines. That's what we are currently doing, and we want to unite all these stakeholders, researchers, and the industry stakeholders together for this initiative. Thank you. That's all from my side.
Thank you. Okay. So next we have Phoebe from Minviro.
Cool, thanks, Stephen, and hi, everyone. So from a bit of a more commercial perspective, I wanted to give you some insight into what Minviro is currently working on. Now, LCAs are fundamentally built on data in the sense of inputs and output materials, emission factors, energy consumptions. However, the main issue we have is it's hard to get primary raw material data from the entire supply chain. And so we have been collaborating with multiple track and trace providers, which is highlighted in point 1. And this idea is not new, but the way we are approaching it, we believe it is rather innovative. And what we've done is we've taken our commercial data collection templates, which we use to apply for life cycle assessments for our commercial clients. We've uploaded these into a track and trace provider. And what we've also done is we've gone beyond LCAs and we've looked at multiple ESG criteria, of which currently is using the Global Battery Alliance 6 key criteria, which include things like forced labor, indigenous rights, and so forth. And what this enables companies to do is share information confidentially and data in order to collect primary data from the entire supply chain. And then following this, we've built an API connection that goes into Minviro's LCA software known as Cycle. And this API connection will automatically generate the lifecycle inventory from the primary raw material data collected from the entire supply chain of the product you are wanting to collect or quantify, I should say. And then you can model it into an LTA format. And then the final API connection we've built in is afterwards, which is then an automated reporting builder. And this allows you to automatically generate a report in accordance to the ISO standards, most typically the 14040 and 14067, and of course present the results in the way that would be most visually valuable to the audience, and with the final aim being to enhance productivity, minimize the administrative costs, and then finally reduce human error. Thanks.
Thank you, Phoebe. Okay, so next we have Damien.
Thank you, Stephen. I first encountered life cycle assessment 25 years ago when studying for my PhD. And at this stage, it was starting to be used not only for comparing products, but also to understand impact potentials of industrial processes, and in the case of my PhD, for technologies for refining and recycling of copper, including using renewable energy. One of the challenges with LCA process or product comparisons for identifying that with a lower environmental impact potential or footprint is the answer actually may be neither. So think V8 Ferrari and V12 Lamborghini. So we must also think for sustainability about rates of consumption and production, products and services consistent with planetary boundaries. So the role of LCA in planetary boundaries is helpfully reviewed in the paper on the left screen by Helwig and et al. Last year. And looking ahead, I'm interested in the connection of industrial ecology and futures methods for, let's say, planetary boundary consistent material flows. And here on the right, introduce the 3 horizons method. So the horizontal axis represents time, and the vertical axis represents constituent elements in the system or economy. So we see in the red line, horizon 1, many aspects are not fit for purpose currently and decline over time, but some elements of today's system actually are worth conserving. So the red line doesn't go down to 0. Going to the green line, we see some seeds for a desirable future in the green, horizon 3, are present today. And here's the interesting part that's often overlooked. For a successful transition between Horizon 1 and Horizon 3, H2, we need to get the stepping stones right. So for life cycle assessment, are we paying enough attention to whether choosing a lower footprint option today delays fast and fair stepping stones to a desirable future? Could we use AI and life cycle assessment tools and minerals and metals databases for a more interactive exploration of technological lock-in? And whilst thinking to desirable futures, what more can we do to ensure that the participatory in the development, work for all, perhaps a role for deliberative democracy when talking about big societal changes, in the case of new technologies and products, a role for social license in design, building on the work of Franks and Cohen. Thank you. Hope this sparks further thoughts on how we can bring science and society together to shape sustainable futures.
Thank you, Damien. Okay, so next we have Mohan, and Mohan broke the rules a little bit and has a couple of slides. So you'll have to tell me when to switch slides, Mohan.
Yeah, this is, thank you, Stephen, for bringing all of us together, and good to meet you, all of you. This is only just a cover slide, so I don't want to spend too much time, but just other than acknowledging the traditional owners. Thank you. Next one, please. Yeah, so one of the things that we have been kind of discussing quite prominently in the past decade or so is about critical minerals. Because if you look at critical minerals are so important underpinnings for modern technologies, whether it is building solar photovoltaics or wind farms or batteries or electric vehicles. So they form fundamental basis for every technology or emerging technologies. And as you see that circle, the wheel, so the inner kind of metals are the traditional metals that we know a lot of information about, their prices, their demand, their supply, where they are produced, how they are, transitioning within a product. But what we don't have is some of those companions, and which becomes very critical to many modern technologies. And these are very exotic, and the list goes on. So there are about 90 naturally occurring elements. 75 have been deemed to be critical to 25 sovereign entities. So they are becoming too critical. And one of the main reasons why they are critical are there's too much market concentration. And then there are also high barriers to entry and poor availability of market information and heterogeneous products, and the market impacts of co-products in many cases. And there are new and emerging substitutes that are coming in. And then most importantly, there's a lot of price volatility and unpredictable commodity prices. So because of these important issues, they become critical. So that means there's so much of these number crunching needs to be done so that we will be able to make a meaningful predictions of how the markets are going to behave. If you can just go to next slide, please. As I said in my previous any mineral is just a mineral, but because we do not have a lot of those market informations, whether it is ESG that a colleague was talking about, the recycling of legacy waste and what is contained in those legacy wastes. So all of these are making them very special and critical minerals. So if we have got more of these information available, perhaps these metals could also be like any other mainstream metals. So the critical mineral kind of thing could be kind of taken away from many of these exotic minerals as well. So I'll come back if there are more questions. Thank you.
Thank you, Mohan. Okay, so next we have Vladimir from Macquarie University.
Okay, thanks. Look, my interest in life cycle assessment really started from the interest to quantify sustainable development. So I found that impact assessment through LCA gives a good way of quantifying the environmental impacts. So, but really, the LCA is as good as the input parameters that go into the model. So the quality of those input parameters is something that, for instance, I was interested in. And how do we get to those? Ideally, we want every company to do the measurements of what they're emitting to the environment. That's the ideal world, but we know that that's very expensive. Just to give you an example, one exercise we did on measuring mercury in power stations is $10,000 only for mercury measurements. Now you can understand that it is very challenging for everything else for them. That's why we go into the commercial databases, such as 𝐒𝐞𝐬𝐬𝐢𝐴 is one of them, but they are also quite challenging is what I found is, for instance, I found that coal mining through the 𝐒𝐞𝐬𝐬𝐢𝐴 database in Australia has worse environmental impacts than, for instance, coal mining in India or China, which didn't make sense. So there's also other issues that came across, for instance, mining of low-grade iron ore and upgrading through beneficiation having lower impacts than mining of a high-grade iron ore, which again didn't have any sense. So that's why I have proposed, and that's the pathway we are going, is looking at the pollutant inventories. So maybe the next tab is, so each country, there are different countries have different pollutant inventories. Australia is NPI, and probably the most advanced. Australian and Canadian are probably the best ones you will get. So for each company, you can get how much they are emitting. The problem, so you can create your own databases, input databases, but the problem there is, first, they're not standard across the countries. Secondly, for instance, Australian allows reporting through sampling, direct measurements or mass balances, fuel analysis or emission factors. So obviously, there's a challenge of non-standard reporting of different emission databases. The proposal is to have an international standard for the reporting databases. And I would like to see actually that we also have, for instance, some economic factors in this report, such as the revenue they create, so we can provide that sustainability reporting across different types of industrial operations. Okay, thanks.
Thank you. And now we have Bernardo.
Thank you, Stephen. Hello, everyone. My name is Bernardo, and I first would like to thank Stephen for organizing this session. Today, I want to focus on an idea that bridges prospective life cycle assessment and the need for better data sets in the minerals and metals supply chain. Prospective LCA is a growing field that explores how systems evolve over time, and we can map its inventories and understand its environmental impacts. A critical component of this methodology involves combining foreground models. So that's the specific processes we analyze, with background models, which often reflect a integrated assessment model like SSP, Remind, and etc. There is a significant challenge here because 𝐒𝐞𝐬𝐬𝐢𝐴 is still the de facto standard for background data sets. And unfortunately, it still offers extremely dated processes or activities, to use another terminology. For example, in my recent work modeling nickel, manganese, cobalt oxide, I discovered that some data sets like manganese concentrate production are over 20 years old. Not only that, but the same data sets are often generalized across several geographies. So when you're trying to build up this background scenario that we use to support our foreground modeling, having this massive mismatch, both temporal and spatial, creates a lot of issues when you're trying to bring over this scenario modeling to LCA, which leads us to prospective life cycle assessment. A potential way to resolve this issue relies on making the field of industrial ecology overall more open and relying on community support. I propose taking inspiration from other fields, particularly data science and machine learning, where collaborative data sets have been foundational. So if you look at the right side of your presentation right now, Platforms like 𝐒𝐫𝐬𝐬𝐞𝐫 leverage global community of contributors that work with data science and machine learning, but also people that are learning and just looking for data sets. They leverage this community and enable the contributors to update data sets, share and refine these data sets collectively. So I wanted to imagine a similar platform for industrial ecology, a collaborative database where researchers and industry professionals can contribute, validate, and share data on mineral and metal supply chains. I personally think that this would not only enhance the temporal and geographic resolution of our data sets that we can use to build up our background models, but also foster transparency and more collaboration across the field. I'm happy to discuss this further with anyone that's interested in. Thank you.
Thank you. Okay, so now Tim Werner from the University of Melbourne.
Thanks, Stephen. So I really zeroed in on the question of how do we get good data to assess mining, and I think most industrial ecologists see their role as someone who sources data, and a small minority of academics in our fields are purely focused on generating raw data that others can analyze. And so we're often forced to trust values provided in large databases like SNL or EcoInvent, but often don't have the time or resources dedicated to independently developing comprehensive data sets that are fit for purpose in the mining sector. And I think we're quite different to other branches of industrial ecology in that we can't rely on comprehensive trade statistics or input-output tables to the same extent, and we rely heavily on disclosures made by the mining industry. But there are so many mines and companies out there with varying degrees of transparency that our efforts to date have left massive information gaps. And so, of course, there's massive structural changes that need to occur to improve how data are disclosed from this really massive, complex global industry. But I guess one tangible thing that I think we can do as academics is to increase the pool of people we might consider to be industrial ecologists. So I've been really fascinated to see how many of my non-industrial ecology colleagues in arts and sciences engage with the mining industry on a really deep level. And I think their proximity could be easily exploited. So they very often meet with or interview companies and communities that are affected by mining. Why not have them insert questions like, hey, what kind of recovery rates do you get for this mine? Is it quite common for mines like this in the area? Do you keep records of yearly production or tailings volumes? And perhaps they might be able to gather additional site-specific data for us with comparatively little additional effort from us. The fields that I've suggested from my slide are just a small sample from my own institution where I've noticed a proximity to mining that I hadn't expected earlier. And a recent study of mine involved the sourcing of new production data sets from Indonesia from an environmental lawyer. A quick Google Scholar search of mining, mineral production, and resources shows 1,400 results from my institution alone in the last few years, suggesting that across Australia and the globe, there's many more that could be helping us if only they knew our data needs. So I think that's just my one message. Thanks.
Thanks, Tim. And now we have Parvez from UTS.
Hello, everyone. Hope you all are enjoying this wonderful informative session. So you face challenge in gathering mineral and metal supply chain data sets to conduct LCA or sustainability analysis, right? Basically, there is a lack of structured data management framework. Due to the lack of data quality, the LCA results are unreliable and non-transparent. Also, the ethical issues and circular economy aspects are currently overlooked in LCA. Now, if I offer a solution to solve these big problems, would you accept? Yes, the offer is integrating AI and blockchain technology into LCA. You can use blockchain technology in data management architecture. The primary and secondary data can be artificially cleaned, formatted, classified, and aggregated. The data will then be stored in blocks for each phase of life and then transmitted via local networks. So this way, it will ensure a high level of transparency, data quality, and traceability. Secondly, to make the overall process ethically compliant and trustworthy, you can apply responsible AI into LCA steps. Finally, you can evaluate circular economy strategy from LCA outputs, considering the supply chain sustainability aspects in 3 key areas like environmental, economic, and social. So this way, we can improve the metal and supply chain data sets and also the LCA analysis in a whole. Thank you.
Thank you, Parvez. Now, last but certainly not least, we've got Wen Li from the University of Melbourne.
Thanks, Stephen. It's my pleasure to share some of the experience we learned from a joint project. Many of the panelists also be part of this project. Stephen, Damien, Parvez worked on this before, and also Tim contribute to this beautiful GIS image. I think many of you already mentioned the problems or challenges facing the LCA with lack of data and a lot of existing database like 𝐒𝐶 use approximations, it's outdated, and also looking at the published LCA results often deal with different methodologies, different function units, scopes, and with incomplete process. So within this project, we're trying to address some of the problems, particularly focusing on the Australian mining activities contributing to the battery value chains. So what we find out is there are actually increasingly available informations, and also we can leverage informations like the GIS, try to find out some of the informations previously we don't have access to. And this allows us to gradually pave the clear pictures about the actual activities happening in the mine site, allow us to do a better LCA. And also we're calling for a more standardized or harmonized approach to define a uniform function unit approach, and also looking at some of the characteristics of the mines and the, from the data frameworks we try to propose. On the other hand, looking at, to build more sophisticated background information, which potentially missing in the existing databases. Another thing I want to stress here is if you look and zoom into the left bottom side from the map, you see different color lines, and you see the mine actual progress organically over the years. So using a single information, single value to represent a mine, sometimes it's a year presented for the environmental impact, and then we're calling for a regular update, try to capture the dynamic behaviors or impact of the mine site. Again, this is the effort from collaborations, and I think this is particularly good revenues to call for a more collective efforts to improve the transparencies of the critical minerals.
Thank you, Wen. And apologies, I misspoke. We actually have Jim West next from CSIRO. Oh, okay. Let me just get your slide up quickly, Jim. Apologies. Just be a second. Okay, thank you. Jim. Jim or James, are you on the call at the minute?
Just can't hear you coming through well.
So I can see that you've unmuted yourself, but I can't hear you at all.
Can you hear me, guys?
I can hear you, Alessio.
So, Jim, you want to come here and use my headset? We can't. I can see you're speaking, but we cannot hear you. just he needs to change office. Give him 15 seconds.
No problem.
He said that his notes are at the computer, so he's going back to his computer.
I guess while we wait for Jim, maybe just start thinking about questions you might want to ask, I guess, the different presenters today. And also have a think about, which of these ideas kind of stand out in your mind as kind of either the most useful or the most interesting to you as well.
Am I on the air now?
Hi. We can hear you now.
Ah, good. Yeah, it's selected the wrong jab. Will I go ahead?
Yep, go for it.
Great. Okay, so mining operations already generate a wealth of data as part of their day-to-day activities. However, whether we as researchers can access and analyse this data depends on motivating the National Statistical Offices, or NSOs, to actually get around to compiling it for us. And unfortunately, many NSOs have very limited technical capacities. So any proposed data collection system we want to put before them needs to be both fairly simple, and crucially, it also needs to have readily available tutorial materials. And I'd contend that online tutorials are crucial for institutionalizing these systems. And that's as opposed, for example, to, say, in-country workshops, which in my experience have a very limited and very transient effect on actually getting any data. Unfortunately, investing in the online resources is expensive, and so that means keeping the system we devise relatively stable over time. And so aiming for a good enough system and then trying to stick with that as far as possible is important. Now, while settling on a simple and well-supported reporting system is critical, that by itself is also not enough to get buy-in from the NSOs. They'll probably require some large and easily communicated benefit to themselves, or at least to the government they serve. So by that, consider what is more likely to motivate a government's interest. So on the one hand, you promise them the ability to determine a sustainability metric, like resource efficiency, or alternatively, you might promise them the ability to track the total value of the metals that they're exporting in their concentrates, with a view to possibly renegotiating royalties contracts. So while our research might focus on sustainability, focusing on the financial benefit for them is much more likely to get a reporting system implemented. So that's basically my main thoughts on the matter. And just for a practical example, you can go look at the metals sections for the economy-wide material flows accounting that's been set up with UNEP. And there we started by modifying an existing methodology to much better fit actual mining realities on the ground. And then we created compilation tools. And finally, we followed up by providing online video and other tutorial course materials. I can't report resounding success there because I haven't commissioned a follow-up like test or an evaluation of how it's performed. But I've been informed that by UNEP that something like about 25 countries have used the system to date. And that's it.
Okay, thank you so much, Jim. So with that in mind, that's the end of our kind of sharing of ideas. And now we're going to do something that I haven't done before, but will hopefully work. I'm going to have a poll for the audience. So hopefully you just got a poll pop up on your screen. And essentially, I want you to kind of vote for basically whoever presented your 4 favorite ideas. And so these could be the people who you thought the idea was the most interesting or has the most potential, or it could just be something you thought was new and exciting to think about. Okay, so we're at about 18 of 23 people have completed this. So I'll just give us maybe 10 more seconds. Okay, so that's almost everyone now. So I guess, can everyone see the... Let me just share the results of the poll here. Okay, let me figure out how to show these results. I think Zoom is kind of ignoring the poll results because it's a Zoom window. So what I'll do is I'll take a screenshot.
Share your screen rather than, yeah.
Let me just... Okay. I guess we can see the results there. So it looks like a lot of people, I guess, liked... Oh, Damien got a lot of votes, so did Bernardo. Jim's idea was quite interesting. A lot of interest in Phoebe's and Peng's as well. But I guess what this shows was that, you know, all of the ideas were potentially interesting to someone. And so I think there's a lot of potential in all the different kind of ideas that were shared today. And so I guess if you are interested in any of them, I mean, feel free to reach out to the various presenters and kind of get in touch with them about it. Because it'd be good to kind of see these ideas kind of see the light of day and, you know, maybe brainstorm ways to, you know, take them to the next level or bring them into reality or kind of just, you know, get some momentum behind them. So thanks, everyone. So now we'll move into our Q&A session. And so to kind of keep it a bit organized, yeah, so I'd like to limit responses to, I guess, questions to 1 minute. We've got about 15 minutes left in this session, so we'll have about 10 minutes, I think, for questions. So if you have a question, feel free to raise your hand.
And there's one in the chat too. So
Okay, so the question in the chat is... So I guess to Bernardo, could you please elaborate on how Kaggle can help in terms of temporal and spatial problems in prospective LCA?
Yeah, thank you for the question, Safdar. When I've mentioned Kaggle, I've mentioned it more from a platform standpoint. It doesn't have to be Kaggle specifically, but just to share a bit of my experience when I was learning a bit more about data analysis and data science. I was taking online courses and I would go to Kaggle for data sets. So if I was learning, for instance, how to use a random forest classifier, which is a particular algorithm, I would need a particular type of data set. I'll just go to Kaggle and try to find a public data set that someone published there. And that can be stuff of like 911 calls and Titanic deaths data set and stuff like that, which if you've done online courses in data science, you're probably familiar with. I was wondering if there could be something similar for industrial ecology, more specific LCA, in which a person could go online and express that a particular data set is outdated or not spatially explicit, and just see if someone would be interested in either making that particular data set public or just trying to add that to a larger data set. So for instance, my example with the nickel manganese cobalt oxide manufacturing, the manganese concentrate data set was 20 years old and replicated across 3 different geographies, but they're all the same data set actually. I mean, imagine if I could go to a platform and say, hey, has anyone worked with this particular data set before? Can you please make it public because I'm trying to use it for a particular project and etc. So it's really just trying to kind of leverage the community that's potentially modeling something from public documents or public processes and try to centralize that into one space. There's a lot to unpack there because, for instance, Kaggle offers free courses and forums and etc. But I think it's just a way to get started about thinking about these kind of platforms.
Thank you, Bernardo. I've got a question from Chang Jiang from Queen's University.
Thank you, Stephen. It's great to be here. I'm Ken from the Queen's Mining Department in Canada. I actually have a question to Phoebe, because I think we didn't talk a lot about the elephant in the room here. It's that a lot of mining companies don't want to share information. You know, no matter it is confidential or not, they try to kind of retain all the data they have. So I have a question to Phoebe that how your company currently handle that confidential information. I mentioned, and I heard that you mentioned kind of the innovative way to handle those information. Could you elaborate more on that? And also, what is your company's position to work with the kind of researchers besides the companies? Thank you.
And not a problem. Thanks for the question. So to the first part, it really depends on where the company is located. So right now we do operate quite old school in the sense of we would have Excel data collection forms that companies would fill in and then either share via a Microsoft Teams group that they've set up or even via email. But it's very inefficient because what ends up happening is one person is responsible for talking to different parts of their company, getting the data, sending it to me then having more questions and vice versa. But what the track and trace platform allows you to do is it's completely confidential source. So if you have an account, you can only send information to registered emails, of which they would then get a notification to log onto the platform to fill in the requirement and then send it back. If you are not part of those verifiers, you do not have any access. You won't be able to see any of this at all. We've had a very good uptake of this in Europe and in the US. In China, our clients in China are more reserved about using this sort of platform, but we're working on how we can support data security here as well. And on the second part, yes, we do have a full functioning R&D team and we love collaborating with lots of researchers, so more than happy to discuss any collaborations there.
Thank you. Thank you, Chair.
Thank you, Phoebe. Damien, there's a question here from Wen. Can you share some thoughts on linking the PB with a unit product LCA? Also, how to address the rebound effect?
Thanks, Wen. So yes, the process in the Unibase it's interesting, and I'm wondering. I mean, it's not a question I've thought about a lot, but I wonder if we are starting in the world of having more data and harnessing AI, if there's a bridge to some of the input-output models work. But yeah, my thinking around some of this was to yeah, to harness that data and really like assessing the rebound effect is I think, you know, key to this whole space. And I think the possibility of AI and more data and information could just help us, you know, even using a bit of the philosophy of Jim in a good enough a way to sense what are some of the important decisions that may or may not take us down one hard path or may lead us to technological lock-in that is then later regretted. So yeah, thinking, exploring new ways and contexts for how to do that. I haven't got a, you know, pre-prepared one to show off, but would be interested in putting heads together with people keen to explore a bit further.
Thank you. Does anyone else have any other questions? Otherwise, I can ask a question. Yeah, I guess, Juliana, I'm very interested in, yeah, I guess the LCA training that you're developing. And given it is kind of mining industry kind of focused, I'm just wondering kind of what sort of response you're getting to that and kind of what level of engagement, like how many students do you have so far? Yeah, I'd be very, I guess, keen to understand what's happening in kind of the LCA training space.
Thanks, Stephen. So currently I have delivered the whole course, like it's a 2-day course, like 8 hours. I delivered online and also in person at the same time at GTK, the Geological Survey of Finland, a few weeks ago. And I got really good feedback from them. Was a quite diverse pool of people working in mining, from geoscientists to geoenvironmental researchers, mining engineers, very diverse range of people. And they responded in a very positive way. They felt like it was useful and also connected with what they are currently doing in their projects at DTK. And more recently, well, actually this week, I delivered the first part of this course. It's more on the basics of LCA, but in the tailored to the mining industry context. To a delegation, a Saudi delegation that came to visit us this week and the last few weeks. So, and they were also very engaged during the sessions. I allowed them to ask many questions, and so it was very interactive. So I think it is promising, and I really wish to put this. To put more effort on this next year, and we will be able to do that thanks to a grant we got recently that supports my current work in circular economy, focus on waste prevention in mining as part of the Global Center for Mineral Security. So yeah, I'm very excited about this, and I also would like to hear about anyone else that could be interested perhaps in giving a guest lecture or something like that, and make it as accessible as possible to many people, you know.
Thank you. It's very interesting to hear that. I guess maybe put your email address in the chat as well. And I saw that Phoebe put hers in there as well. I guess if anyone wants to reach out about that. I think we've got time for maybe one last question if anyone's got anything burning. Okay, Masaharu.
Yes. Thanks. Hi, hi everyone. Masaharu Motoshita from AIST Japan, and I'm very enjoying a lot of your presentations. And my question is not too specific. It's not too specific presenters, but if you have any of the ideas, please share with me. So my question is about how we can motivate or maybe encourage our, the stakeholders to provide the reliable the information, the data sets, or maybe the implementation of their more sustainable, the management of the mining or metal production. So of course, theoretically, we need the high the quality data and also reliable data and comprehensive data. But the point is how we can encourage or motivate them. So if any of you have any idea on that, I do appreciate it.
Thank you. Okay, does anyone have a response for Masaharu? I guess, Jim, maybe you spoke a little bit about how governments could be, I guess, an actor that kind of helps, I guess, promote, I guess, release the data. Do you have any thoughts on this?
Yeah. I mean, one of the points I raised is you've got to try and, if there's governments are the ones that have the authority, the power to actually, if not compel, well, they can compel reporting, but also, you know, it's a general responsibility of them. It's accepted that, you know, government will be a place with a mandate to collect statistics. But to motivate the government, they're less motivated by things, especially in developing countries, which are important for mining. The eyes tend to glaze over if you're talking about some high-level sustainability statistic in many cases. But if you can bring something to the table saying, look, there's every chance that you want transparency in these mining companies, you want them to be reporting to you detailed data, because if they're not, I as an ex-geologist, one that I've seen eyes light up is I say, this is how I would steal from you. I would say the financials are well taken care of, but the concentrates that are getting exported, often they carry other minerals. There's no reporting on the amount of the things of value that are actually going offshore. And if you make clear, well, people could be underreporting or not reporting stuff that's there that's highly valuable to you. You could be paying extremely low royalties for something that's worth a lot more money than you've been led to believe. That's, in my experience, certainly gets interest. I know there's not a lot of other examples that would be comparable to that, but that's one example I'd bring up.
Okay, thank you, Jim. So I think that's the end of our Q&A session. I think this was a great session overall. It's great to get all the different ideas from everyone, and I think, you know, so many people for being willing to contribute and kind of participate in this session. Once again, I'd just like to encourage you all to kind of look at the full IE Day program and see what other sessions may interest you. I'll just put in the chat again the link to the full program for IE Day. The next session will start in an hour's time, and that's actually going to be a session which is based on student posters. And we've tried to motivate the students where they get a $300 prize if they've got the $300 US, if they've got the best poster. So we're expecting fairly high quality in the next session, which starts in an hour's time. So once again, thank you all for coming. I think it's been really good. So yeah, let's give a round of applause.
Thanks for organizing, Stephen.
Bye-bye.
Thank you. Thank you
Thanks.
for inviting me.